Okay, so we are going to continue with our section today. So the last two subtopic that we have is simple histogram. So we are going to draw using this package. So please refer to our notes for the code. All right. So the function that we have is histogram, H-I-S-T, his. And the data that we are going to use is iris, and this is our variable, sepal.length. And then this is the name, this is the label, and this is the column, the color of the column. So let's try to run. Okay, so this is our histogram. So based on the data from the iris, we only just want to focus on the sepal length. So this is the value. And as you can see, HIST, the function his, in the bracket iris, $sign, sepal.length, it actually creates a histogram for the variable. So our variable is sepal.length. So sepal.length is actually from the iris data set. And then as usual, the title of the histogram, and then breaks equal to 10 actually divide the data into 10 bins or into 10 interval. So this actually gives you basic view of how sepal length values are distributed. And then next, we are trying to create a histogram with normal curve. Okay, so we are using different data. So let's try to run for this one. This time around, I save the histogram under H. So this is the name of our objects. All right. So if you can see here under our environment, there's something extra named H. So this is under H. We have integer counts, density, etc. So what we are interested actually, we just want to look at the histogram. So this is based on our histogram. Since I use the color light gray, so this is what we get. So this is the name, this is the label for x-axis, and then the breaks equal to x and frequency equals to false. So when frequency equals to false, the plots will automatically probability using probability density instead of using frequency. This is what we needed if we want to overlay a curve. So we save it under H because we want to modify it later. So if you want to overlay the normal density, so let's try to put the nodes. So for x fit, so let's try to run this value first. Okay, so we have extra line on the same graph. So for the first one, sequence in the bracket, so the explanation like over here, we have the length equals to 40. So this is actually generate 40 equals space value between the minimum and the maximum value of mile per gallon. And then we do have the D norm, and then in the bracket for the explanation, the D norm actually calculates the normal probability density at those values using the mean and the standard deviation of mile per gallon mpg. And then lines actually, the function lines draw the curve on top of the histogram in blue with line width equals to 2. So this actually let us compare the real data distribution with the theoretical normal distribution. All right, so let's try to do histogram by facet of groups. So we do not want to look at this. Okay. So I'm going to use data penguin. So make sure you have it in your R. So if you do not have it, library. Okay, so I have it now. So what happened is that I'm going to let the parameter m f row equals to c, and then in the bracket 1 by 3. So what does it mean is actually divides the plotting area into 1 row and 3 columns so that we can display multiple histograms side by side. And then for function 4, and then in the bracket SP in levels. So this is actually loop over each penguin species because we do have different penguin species and we do not want to do it one by one. So we are going to loop over each penguin species. So inside the loop, if you look at the inside the loop, we only select only the bill length for that species, the bill length. So that's why penguin dollar sign bill underscore length underscore mm. So this actually create histogram with 10 bins, salmon colored bars, and a species specific title. So let's try to do that. Let's see what happens. Okay, so that's why we do have three different histograms. This is for the first penguin, and then this is the second one, and then this is the third one. So actually, you have to reset the plotting after you set the parameter MF row in the bracket C1 to 1 row 3 column, because after this, if you don't reset it, the next graph will use the same parameter. So we do not want it to be like that. So after that, always reset it to the original. So one column, one row. Okay, so this will reset your plotting layout back to default setting. So actually, why do we need to do comparison for this one? Because it is very easy for you to check. Compare each penguin group by group at once rather than doing it one um, histogram at a time. Okay. Okay, so the next subtopic we are going to do for the last graph that we have, which is box plot. So the first one I'm going to draw for single box plot. So for single box plot, what function that we are going to have is box plot. Again, this is our data, and then I'm going to use petal.length, and then this is the title, the Y label, and then this is the color. So let's try to run this data. So we got one box plot right now, and our y-axis is petal.length according to what we put it here. And then actually, uh, the box plot tells R to draw a box plot for the number of numeric vector. So petal.length is numeric vector from the built-in iris dataset. We already have the variable. And then next, how to read this box plot. When you look at the box plot, you notice that in the middle we have the thick line. So this is actually our median or quartile 2. And then the first border is actually we have the quartile 1 to quartile 3. The lowest should be quartile 1, and then this is our quartile 3. And then the whisker, it must be between 1.5 of the RQR from the box, interquartile range from the box. And then any points further than the whiskers, actually it is outliers. So for this data, we do not have any outliers. So let's try to do the next box plot. So for group box plot, I'm going to copy the code. All right, so this time around, let's try to run it first. Let's see what happened. Okay, so for this data, if you notice that the box plot actually uses the formula interface. So y tilde x. So plot petal.length. Petal.length is actually numerical data by grouping the variable species. So we know that variable species is factor with 3 levels. So if you look at the graph, we do have Setosa, Persicolor, and Virginica. And then data equals to iris. Actually, we tells R to look for both variables in the iris data frame. And then the axis, the title, and then the label for X group. For the color, since we have three different group, three different species, we want it to be light blue, light pink, and light green. So this is the color vector, one color per group. And again, if you notice, we look at the median. So median across our box plot. So we do have across our box plots. And then note that we do have outliers per species for versicolor and setosa. We do not have any outliers for Virginica. Okay. So that's all if you want to use Boxplot to compare your data. So that's all for graph using base package. Thank you.